Hello and welcome to this webinar on Nuke 12.1 updates. My name is Roy Yang and I'm a creative specialist at Foundry. Today we're gonna take a look at three core areas of this latest Nuke update: artist-friendly UI, core performance improvement, and a new workflow for multi-shot review. Without further ado, let's dive into it. The first new feature is the Shuffle node. For Nuke 12.1, we're introducing an updated version of the Shuffle node. The new Shuffle node will replace both the Shuffle and the Shuffle copy nodes. This has an updated, more user-friendly UI, can support 1 or 2 input, and will support up to 8 channels per layer. The update node also improves on stability and offers constant channel ordering relative to the previous Shuffle node. Since all my sample scripts are created in Nuke Studio, let's launch them from the timeline. First, let's take a look at the Shuffle and Shuffle copy node in the previous versions. The old Shuffle node has 2 input layers on the top, and there's 2 output layers on the right. It uses a lot of squares and arrows to link in between the channels. I'll say it'll take you some time to familiar with this pattern. On the left hand, we have the new designed Shuffle node in Nuke 12.1. You'll notice that there's a lot of lines and noodles in between the channels. So you can simply just click off to unlink these channels, or you can double-click to link the channels or hold down the Control key to connect the channels by name. Obviously, if you don't have any name matching, it won't connect. You can also connect channel by drag and drop the noodles or the lines. There's also a shortcut for this. If you hold on the Control key and drag and drop, it will link the current channel and all the channels below. Vice versa, if you hold on Control and Shift key, it will connect current channel and all the channels above. If you hold down the Alt key, drag and drop to the right, and the current channel will be linked to all the output channels on the right. You can drag and drop panels from left to right to connect all the channels. And there's another way to unlink all the channels. You can hold on the Control key to hit the black or the white socket to disconnect it. In this way, you are setting all the channels either in black or white. So for the Shuffle copy function, first of all, you'll understand the B channel, B pipe, is for the mainstream. And now you need to connect the A pipe to another image. And now you can switch another input layer from B to A to select the layers you want to copy from. Let's create another layer for the output. Just like the previous versions, we support up to 8 channels per layer. Again, we can link all the channels by drag and drop panels. We can also drag panels up and down to reorder the links. This newly designed Shuffle node in Nuke 12.1 brings us much better user experience. The next new feature is the Lens Distortion workflow improvements. With Nuke 12.1, we have revamped the updated Lens Distortion node to offer a more intuitive experience. Let's take a look at that in action. In this script, we have Lens Distortion node connect to a gridboard and original plate. For the gridboard analysis, you can go to the new analysis panel and click on the preview option. Now you have the settings of the feature of the numbers and the other options. Usually I use my mouse over and scroll down to the sweep point. which is not too many and not too less point for calculation. So 1600 is good for this case. And we can hit detect. Now you'll notice that all the lines change color from blue to yellow, which means now you can go to the viewer and start editing those lines, or if you want to add some lines as you wish. You can even delete some of the lines you don't like. So now here I can actually add points and form a line for calculation. Once this is done, you can hit solve. And the solve will give you a result right away, because in the Lens Distortion tab, now the undistort mode is by default. And you notice that the solve error rate is quite high in this case, so you can play with the threshold around 5 or 6 to reject all the lines and the points it's not good enough, and solve it again. And you will lower down your error rate from 4 to 0.8, which is below 1, which is good. So this is a great analysis. For the line analysis, first of all, you take a look at your fisheye lens shot. There's a lot of straight lines in this shot, which is supposed to be straight. It's bent now. You can go to the Lens Distortion node, and under the Analysis tab, there are editing and drawing tools for you to draw lines. And these tools are on the left-hand side of the viewport as well. So let's zoom in and find the straight lines in this shot. And you need to draw at least 4 lines for calculation. You hit enter and you can draw another line. And then we have a long straight line here for calculation. We return to the panel and you can solve from there. And if you have more time, you can draw more lines in this shot to get a better result. Under the Lens Distortion tab, by default, we now have automatic bounding box as an option, which is very nice. You could also switch the output format from input to bounding box, and you can see the bounding box preserved a lot of information around the edge. The GridWarp Tracker node has also been updated. We now introduce new export options, which allow you to export tracking data from the GridWarp Tracker. Now let's take a look from the script. Here we have a GridWarp Tracker already being tracked by using the smart vector information. Under the adjustment layer, now you can pick any point from the grid to export. You have 3 export options here: tracker bait, tracker linked, and transform bait. In this case, I'm going to export a tracker bait first. Now you can see this tracker is getting all the transform information from smart vector, which is awesome. You could also use the selection tool to select more than one point, a group of points to export. You can even select the whole grid to export. Right-click on the point, and now I want to export as a linked tracker. A linked tracker, if you double-click it, you can see the green line in between the nodes, which means all these points we just exported are driven by the GridWarp Tracker. The next new feature is CaraVR GPU caching. This is a CaraVR 6 camera solve in a stitch shot, which has a chain of GPU nodes. In Nuke 12.1, we moved all the cache from CPU to GPU. It will keep all the data on the GPU and save a lot of time transforming data back and forth from CPU. And for this shot, now the render time is down to almost 65%. The longer the GPU node chain, the better the acceleration. We also updated Bilateral node. In Nuke 12.1, we have merged C Bilateral with the Nuke version of the node, adding additional functionality and GPU support. Let's take a look at it from the script. Here we have a new Bilateral node in Nuke 12.1. You'll notice that we introduced a new median filter. And this Bilateral is also connected to a guide input, which is the depth map. You can play with the size, positional sigma, and color sigma to get the result you want. And now the Bilateral is powered by GPU because we merged with the C Bilateral node. Since the Bilateral node can help us to remove a lot of detail from the image while preserve the edge, and now we can use it to create our own customized sharpen tool. So this is the original image, and we use Bilateral to blur it. And we divide the result by the original plate to get the detail. And we can emphasize the detail by using a gray node to darken it, and multiply this result back to the original plate. We can compare the original plate with our sharpen tool. The result is pretty nice. We could also compare our customized sharpen tool to Nuke sharpen tool. For the Nuke sharpen tool, it'll introduce a lot of dark pixels around the edge. So it's easy to tell which one is better. So I'll say Nuke is really a tool to create your own tools. So we can save this workflow as a gizmo to be used in the future or share with others. In Nuke 12.1, we also merged C spherical transform with the Nuke version of the node, adding additional functionality and GPU support. Here we have a sample script of CaraVR 360 stitch. We have 3 fisheye lens camera input, and we follow by a C camera solve node to solve the cameras. And we used C stitcher to stitch the camera together. Then you'll notice that it's not always perfect. There's a dark edge and there's a black hole in a tripod location, which needs to be fixed. So now we could apply a split and join workflow and insert a lot of treatment in between to fix those issues. So in camera 1, we apply roto node to roto out those dark edges. In camera 2, we do the same on the edge dark edges, and we also apply a SP-line warp to warp the edge to match the other camera much better. And then we join the views together. Now we have a better result. To fix the dark hole in the bottom, which is the tripod location, we apply lat-long paint workflow. So first of all, the spherical transform node is transferring the projection from lat-long to rectilinear space, and we point our viewpoint to the bottom. And we apply roto paint mode to patch it. We apply another spherical transform node to change the lat-long space back, and then now we can merge this result back to the original plate, and the shot is done. And more importantly, we can apply the spherical transform node in the bottom to check the result. And now we introduce a new projection node, which is a mirror ball option. And this is perfect for image-based lighting, map check, 3D. And you could also rotate projections by hold down the Control and Alt key and drag the camera and check the result. And the next update is about ParticleBlinkScript. For Nuke 12.1, we have added the ParticleBlinkScript node. This node works in a similar way to the BlinkScript node. It allows users to write BlinkScript which operate on particles. This enables you to write your own particle nodes to create the specific particle effects you want. And let's take a look at them from the scripts. First of all, let's take a look at how ParticleBlinkScript works. You can see we have a 3D card in the 3D space, and there is a particle emitter connected to it. And now the card is shooting a stream of particle into the 3D space. We can now attach a ParticleBlinkScript to it. In this new node, there is a tab called Kernel Source. There's a ParticleBlinkScript example there. It basically describes how you want to change the behavior of the particles. And here I have a sample script here. And I can copy and paste here. After we compile it, now you can take a look at the result. Now you can see the particles now are constrained to a sphere surface. And let's take a look at the Blink script we just copied to the kernel. And it basically describes the particle parameters such as translate, rotate, scale, uniform scale, radius to look at the sphere surface. Since we know ParticleBlinkScript is new to a lot of compers, so here we created 14 ParticleBlinkScript gizmos for you to play with. And let's take a quick look at them. Here we have 14 ParticleBlinkScript gizmos. First, let's take a look at the particle by age gizmo. Once you attach the gizmo to the particle stream, you'll notice that now the color of the particle varies in 4 different time zones. And the color can be changed in the gizmo control panel. And the next gizmo we're going to look at is cylinder flow. Here we have a particle stream shooting from a 3D card. Once we attach the gizmo to it, you'll notice that the particles are now flowing around the surface of the cylinder. And you can change the cylinder position and rotation in the control panel. And thanks to the GPU card, this function is almost real time. And the next one is quite fun, called Fuse. We're shooting sphere inside a cube. And once you attach the particle fuse gizmo to it, you'll notice that the particles start to merge when they hit each other. And you can play with the fuse behavior by changing the fuse distance in the control panel. And the next one called helix flow. First of all, you can change the shape of the particle by using radio and noise node. And then we can emit them from a card on the ground. Once we attach the gizmo to it, You'll notice that our particles are now following a three-dimensional curve. And you can change the effect and play with it in the control panel of Helix Flow gizmo. In case you want to learn from these 14 ParticleBlinkScript gizmos, we exposed all those Blink script for you to look at. Under the Gizmo Node tab, there's a button called Copy to Group. It'll generate a group node out of the gizmo once you open the group node, and you can get the ParticleBlinkScript from there. As we all know, the compers now often find themselves in the 3D scene. Many times, they need to sync the 3D effect with any change in the scene. So knowing how to use ParticleBlinkScript in Nuke is really a strong asset for compers now, which I fully recommend. The next update is HighDPI Windows and Linux support. Nuke 12.1 adds support for UI scaling when using high-resolution monitors on Windows and Linux. This brings all the platform in line with high-res display support added for macOS in Nuke 12.0. And here I have two 4K display screen capture, both from Windows, side by side. The left-hand side is Nuke 12.0, and Nuke 12.1 is on the right-hand side. When I zoom in, you can see the Nuke 12.1 menus and node graph has much higher resolution now, which is very important to the users. And the next new feature is bin and track item version linking. In this release, we're introducing a new behavior that allows linking of source clip versions between a project bin item and its corresponding track items. And here I have source clip in the project bin. And it has three versions. Version 11, which you've already seen, is color-coded in blue. Version 12 is in pink, and the version 13 is in yellow. This source clip was cut into two shots, side by side in the sequence. And it also appeared in the spreadsheet. Just as the previous version, all these items are not linked, and there's a new link status icon showing unlinked here. In the current status, if the source clip version changed, the rest of the item won't follow. In Nuke 12.1, now we have linking feature under the version tab. If I choose link all, you'll notice that all the item versions are lined up. You could also break the link on any of the items by selecting Unlink Selected. You'll notice that the link status icon changed to Mix. And now if you version up the source clip, there's only one shot unlinked, while the rest of the items still follow. If you want to relink this particular shot, you could right-click, under the Version tab, go to Link Selected. There are two options here. You could either match the shot version to the bin version, or use the track item version to force the rest of the item to sync with this shot. There are also Linking Status tab and the version linking options from the spreadsheet. And in Nuke Preference Setting, there is an option for whether or not linking bin and track item version by default on import. The next update is QuickTime Audio Multi-OS support. We're expanding native support of MOV containers containing audio to Linux and Windows. You will now be able to import these MOVs directly into Nuke Studio, Hiero, and Hiero Player without the need to extract and import the audio as a separate WAV file. We also introduced surround sound audio support in 12.1.
Now we have multi-channel audio support in Nuke Studio, Hiero, and Hiero Player. Multi-channel audio patching has been added to the timeline. When you import 5.1 and 7.1 or individual audio files and place them onto your timeline, the audio tracks will now have the ability to patch to different output speakers. Let's take a look at this function in action. Here I have a 7.1 8-channel audio clip in the project bin. Once I drop it onto the timeline, it splits into 8 audio tracks. You can see audio 7 and audio 8 already been patched to the left and the right channel. And you can click on the stereo sound icon to patch the rest of the audio manually. You could also export this surround sound from the export panel. Under the export structure, you can switch the content to audio export. And in the output channel menu, you'll find 5.1 and 7.1 options there. And the audio output can be set up using monitor out devices or specific audio cards. As you know, Hiero Player can be used as a flipbook tool. In Nuke 12.1, we have improved the launch speed of Hiero Player across all operation systems. We have been able to increase launch speeds for new instances of Hiero Player on Windows and Mac OS by a factor of 1.2 times, while on the Linux, we're seeing an increase of up to 1.5 times. Hiero Player, Hiero, and the Nuke Studio launch from terminal has been expanded and offered the ability to dynamically load files and folders into the project bin by entering the file paths in terminal. This speeds up launching Nuke Studio, Hiero, and Hiero Player to review any supported file type. First, I want to show you how to directly open project file in Hiero Player from terminal. For example, in my prompt window, I could enter Hiero Player launch command and drag and drop my project file from the folder. Once I hit the enter, the project will be opened by Hiero Player right after. Next, I'm going to show you how to use Hiero Player as a flipbook tool. As usual, you can select your output node and hit Alt F. And it will launch Flipbook control panel for you. Make sure Hiero Player is our flipbook option here. You'll notice that the OCIO settings will be passed down to Hiero Player for review, which is very cool. Once you hit OK, then the Hiero Player will launch and play back the shot. In case you have another version to compare, for example, I'll color grade another pass here. Again, we flipbook to Hiero Player. When you see the player icon is flashing, it means our second shot is already being played back there. Now you can drag and drop the first version to the viewport to compare. The wipe tool allows you to move, rotate, and change the transparency. And you could also switch the layout to horizontal or vertical. In this new release, We also updated file formats and SDK. Nuke now supports DNxHR MXF writing, as well as reading DNxHR MOVs. The Array camera updates include Array RAW SDK, CUDA GPU debugging, Codex HDE.ARX Array RAW, and Alexa Mini LF support. Lastly, we also added QuickTime and MXF improvements. So, these are all the 12.1 new features I want to share with you today. If you have any questions, please let us know. And we will continue offering you the webinars and online sessions during this difficult time. Thank you for your time with us. Stay strong and happy comping.